Welcome back, Bryan Vikings. We're going to talk about states of matter in our pre-AP chemistry class, and it is you're going to look at your notes. There should be a table that says solid, liquid, and gas, and it should just be a open blank sections for you to take notes in. So if you just write down solid on one column, liquid in the middle column, and then gas in another column, you can do the same thing without the actual note printout. Now, for a solid, it is, there's three states of matter. There's the solid, liquid, and gas. Well, a solid is matter that has a definite shape and a definite volume. So it will not take the shape of its container. It is just the shape of the solid. And it will not take the volume of the container as well. Now the particles are very, very closely packed, like you can see right here on the right side. Now the molecules they do move slightly, so they do vibrate a little bit. They do have some kind of motion. They're not just absolutely fixed. And always kind of remember that molecules are always still wiggling at least a little bit, but they are not compressible. So if you push down on something like a Lego, if you step on that Lego does not compress, and it hurts a lot, right? Because it's compressing the liquids or compressing your skin instead. So they are very closely packed, and they move only slightly. So they won't squish. Now a liquid is a form of matter that has an indefinite shape, but it still has a definite volume. So its volume is still fixed, but it will take the shape of its container. Now if you see, the particles right here are kind of loosely packed, or they're loosely held together. They are still close together, but now they can actually trade places with one another. They have enough energy that they can move, this molecule can move to another molecule over here. Now the particles can flow past one another, and they are mostly incompressible. We're just going to go ahead and say that they are incompressible. Liquids are not compressible. Now a gas is a form of matter that has a indefinite shape and an indefinite volume. Now the particles are spaced very far apart, and particles will easily move past one another, or they will flow past one another. And so they are easily compressible, which means that there's a lot of empty space in between here, so you can compress that empty space and get those gas particles closer together. So they will take the entire shape of the container, and they will expand to fill their container. Alright, now plasma is something you may have heard of. Plasma is not tested, but it is an official state of matter. It's found in the sun or in lightning, but you can also make it in your microwave. Go Google that with some grapes. Don't tell anybody I told you that. Don't go do that. Don't try that at home, because you'll break your microwave. But it's a high energy state in which ions exist in a gas-like form. So it essentially is a gas, but the electrons have been pulled off, so they're just ionized. Now, it can be found in the stars and lightning. So let's just review. This is what you absolutely must know for your test. A solid has a definite shape and a definite volume, and it's not compressible. A liquid is indefinite shape because it takes the shape of its container, but it is a definite volume, but it is also incompressible. Now a gas is indefinite shape, it has an indefinite volume, but it is compressible. So you'd be able to make a Venn diagram out of that, and that's normally an activity that I do with solids, liquids, and gases. Now there's a quick simulation which I'll pull up. See if I can pull up here. This simulation will show the states of matter. Now we have four substances on the left, on the right. We have neon, argon, oxygen, and water. So let's take a look at neon. It is a solid because they're packed together, and you can see them wiggling. All right. Now let's go ahead and see what the liquid looks like. You can tell that they're wiggling some more, and they have what we call translational motion. So maybe this one molecule might move off to the other one. Now this one right here, this one just evaporated, and now it's going to come back and it's going to track back down. And this one evaporated and it's now leaving, and they're starting to become a gas, but then they eventually come back and become a liquid. Now this is a gas, what a gas looks like. See how it takes up the entire container from top to bottom and left to right, and they're always moving, always in constant motion. And they're bouncing off each other, they're bouncing off the walls in the container. That walls of the container is what we call, the collisions with the container is what we call pressure. Alright? So argon is very much the same. It's very much the same as neon gas. Now oxygen is a little different. Let's take a look at oxygen. Oxygen is diatomic, which means there's two oxygens. You've heard of O2 before? Well, that's oxygen. There's O2. So their two oxygen molecules are bonded together. Now they're kind of sticking together here, and notice that for all of these, all the liquids are always still kind of clumped together, even though they're still taking the trying to take the shape of their container. Now this gas is taking the shape of its container right here, and it's moving around. Now let's take a look at water. Water is very special because it does this cool little hexagonal shape. It likes to kind of form. You see these bonds right here, and this is why water has a lower density as a solid than it does as a liquid. You see, as a liquid, it will have a higher density. And so that's really cool how that works, but you can still see that the liquids are not compressible here, and then you have a gas. Alright, so even just to show you what I mean by not compressible, let's take a look at this water right here. It's a gas right here, and let's see if we can make it a liquid. Here we can maybe cool it down and make it a liquid, but even if I try to compress it even more, eventually you'll lose the top. You just cannot compress them. Alright then, that's going to be it, I think. You have one little thing. You need to be able to do this. You need to be able to draw a picture of a solid, a liquid, and a gas at the particle level. So that is essentially these pictures that I showed you right here. You need to be able to draw those on a piece of paper. Make sure that you can draw those in your notes, because that's going to be important. Alright, that's going to be it. Have a great day.